RBLX is a quantitative and semi-quantitative RBI software suite. RBLX covers the following asset types: pressure systems, atmospheric storage tanks, pipelines, pressure relief devices, and bespoke module. RBLX has additional features: API 571 damage mechanisms on top of API 581. It can calculate creep, which is not in API 581. RBLX has a unique non-intrusive inspection module. It has a pipeline module, which is not in API 581. RBLX can facilitate integrity operating windows, IOWs.
Each client has a specific URL, and each user has a specific username and password. You can also see two risk matrices. One of them is area-based, which represents safety, and another one is financial-based. In the library, you can easily upload or drag and drop all the documents. All data can be uploaded into RBLX using Excel sheets. And we can easily search the equipment number V101 in the top right here. So within the Data tab, there are three sub-tabs: Design and Installation, Operating and Process, and finally Inspection tabs. We should input data in each of these areas. It should be noted that in a real project, you will not input data manually into the software. There is an import Excel sheet which you fill with available data and then upload into the software. If there is not enough data to do a quantitative assessment, you may tick the qualitative assessment checkbox, which contains minimal mandatory fields. The Inspection Data tab includes three sub-tabs: Intrusive and Non-Intrusive Inspection, External Inspection, and Thickness Measurement. The software will then calculate the long-term and the short-term corrosion rates. The software has automatically identified the applicable corrosion or thinning mechanisms based on API 581. Also, the software has identified the potential corrosion mechanisms according to API 571. In fact, API 581 and API 571 have both been integrated here. A corrosion rate can be calculated by the software based on theoretical models. So these damages are represented in three different categories. We've got cracking and mechanical, metallurgical, and external. Applicable damage mechanisms have automatically been identified by RBLX. And with some additional data, the POF will be calculated and presented in a category between 1 and 5. The POFs are summarized in 4 categories. The overall POF is determined based on the calculated damage factors in API 581. Similar to other parts of RBLX, the COF can be overridden with a good justification if required, as seen there. The COF has also been shown in a bar chart. In RBLX, 2 different risk matrices have been provided: an API 5x5 and an ADNOC 6x6 risk matrix. Risk has already been calculated based on the POFs and COF from previous stages. In the 6x6 risk matrix, unmitigated and mitigated risk matrices for the area and financial risks have been developed. In the mitigated risk matrix, it's assumed that the proposed inspection has been completed and the risk is predicted. So therefore, it shows how the risk will be reduced if the proposed inspection plan is performed. Now that we have the risk for the component, and we need to define the inspection plans, including the proposed inspection date and the techniques and the coverage. So in order to define the next inspection date, it's important that the RBI software is able to predict the risk in the future. According to API 581, a risk target should be defined. When the risk reaches this risk target, this date would be a potential date for the next inspection. However, RBLX has also calculated the remaining life, which its calculations are slightly different from RBI. Based on this remaining life, we will get another date. Some companies might have to follow their company or national rules for the inspection date. Regarding the inspection techniques and coverage, RBLX has already made some recommendations here. If a component needs an FFS assessment, The software will identify that requirement in this area. RBLX has this log tab, which will give you all the calculations results based on API 581. RBLX can also facilitate integrity operating windows following API 584. NII is non-intrusive inspection. It's a unique model which is based on HOIS RP103. Basically, using this module, you can tell if a vessel can be inspected on stream instead of opening it. You can see in this example, we've divided the equipment into 5 parts. The final conclusion here is that NII is possible. The NII inspection plan for the localized loss of wall thickness is suggested as follows. You can see 100% coverage of all zones using 0-degree corrosion mapping. After completing the RBI assessment on all the components and also NII if required, an inspection engineer can finalize the inspection plans. The recommended inspection date would be based on RBI, remaining life, company rules, and planned turnaround date. There's 4 types of reporting. Written scheme of examination, this is in Word format. We've got NII report, which is in PDF format. We have RBI reports in PDF format, and we can also export all the data into an Excel sheet. To summarize, as you've noticed, although thousands of coding lines and tables and equations are behind the software, RBLX is extremely user-friendly. And in fact, with a short training course, you'll be able to perform RBI on the most complex equipment in the software. RBLX isn't a black box. All calculations can be repeated based on the API standards and compared with the RBLX logs. RBLX covers almost all types of equipment, so there's no need to use several different bits of software. Although RBLX has many enhanced features compared to other software solutions, it is very cost effective. If you need to get access to the demo version of RBLX for a short period of time, or if you need any more information, or if you need to arrange a live demonstration for your company, please just get in touch.